Yay, the plumber came. He was actually 3 minutes early, and that was a great sign for the week. But let me back up because there's been so much work leading up to this point. Today is all about the DWB system. What is that? I call it sewer lines. You'll hear me call it waste lines, but technically D is for drain and refers to water from sinks, showers, washing machines, that kind of thing. W is for waste, that's your toilets, that's self-explanatory, and B is for vent. To get started in this house, all the existing plumbing and water supply and gas lines had to come out and be removed. Just looking at what got pulled out tells the story of why it all had to go and be replaced from scratch. The waste system in this house, like most others of its era, was made from cast iron, lead, and underground, sometimes clay. Understanding how everything was connected and what it did and where it went was a nightmare all in and of itself. I spent a lot of time in the attic tracing pipes and trying to understand how the existing plumbing was connected. And right behind that chase is the one that's going down. So what is this one? What is that?
It doesn't look like it.
It's got to be a vent. Why would you have a vent that big? It's not draining it. I mean, because it's connected way up here.
Mm-hmm.
So that's just some big old vent. Where does that go? Let it go down there. Okay. Ow. All right. Okay, that's going in the wall. Okay, that's going straight down the wall. Time, a corrosive environment, a lot of use was not the system's friend. As things broke and leaked, modifications were made, which caused more leaks and more serious damage to the structure. The addition of bathrooms meant they had to find a way to run more pipe, and the solution was usually to just put it on the outside of the house, which is ugly and subject to an even harsher unprotected environment. Look at some of the damage done. This pipe was just split open. The cast iron pipes exposed in the basement crumbled, and this is what can be seen. Think about what's going on inside the walls that we can't see. It's easy to understand why insurance companies require that all the plumbing be replaced before they'll insure a house like this. Almost all the house's sewer line systems work off gravity. Water flows downhill, and in some situations, a downhill slope out of a building can't be achieved. And then you have to get a special collection pit and a grinding lift or a sewage ejector pump. I've already talked to you about all the problems getting the proper downward slope in the drain pipes from this house, and thank goodness we managed to avoid a sewer ejector pump. Go back and check out the earlier videos on the issues if you haven't already watched them. The link is in the description below. But there are more issues than just slope in getting a waste system to work properly. So back to the problem at hand, fixing the plumbing in this house. The first step was to get a connection to the city's main sewer line. You may remember that disaster. Next, just like new construction, all the plumbing has to be put in the ground under the basement slab. And then it has to be tested to make sure it's working properly and not leaking. And that's the task for today. You already saw all the preparation that went on to get ready. A major step was for me to come up with a design for the basement. The plumber needs to know where every sink, toilet, shower, everything's going to be, so the waste system can be designed and installed. David, the plumber, and I have already gone over this several times to work out all the kinks and mark the plans on the walls. David is here starting the plumbing. We've spent maybe an hour this morning figuring everything out just to be sure. He's got all the markings, vent, drain. The main line's going to come in over here. And this is actually one of the more critical markings because it's the center of the toilet from the two walls where it's going to be placed. And those are critical because of code. Everything else we have a little bit of wiggle room in. They've already busted out some big old drain lines that were here, cast iron, not in good shape. And now he's digging the line. That's Jeff over there. He's digging into where the kitchen will be. And I learned something. It was important that they do this part of the digging because code lets you dig down to undisturbed ground and place your pipe. If you're in disturbed ground, there's more requirements about sand and what you have to do. You don't want the pipe to shift or move after it's in place. It could mess up the slope and cause the water not to drain. So anyway, it's really happening.
Where you're standing? Yeah. Yep. That whole access pit right there. And then I'm gonna get the sledgehammer to bust out this concrete right here, because we got to put a drain right here.
So right now they're working on the slope or the grade of the line, and the problem is this trench keeps collapsing. The sand is so soft, so they're not going to walk on the sides at all. They're going to treat it like a little highway and only walk down in the trench and try not to touch the sides at all. So basically, gone to get the core driller, and they're going to drill through this wall. That's the lowest spot, and everything will be built from there. And hopefully by the time we get all the way around and over to the far bathroom, we'll still have enough slope. It's a little darker over here, but that's the run that's going over to where the washing machine will be. And we did spend most of our time working on the venting aspect. We had to come up with a kind of an awkward solution. We're going to go up here and go through a cabinet in the back pantry of the kitchen. And I'll show you why later.
Then we should be able to come in with the 2 4-inch lines and the 3 2-inch lines. Yeah, I'm good.
Let me digress a little bit. Did you know that an important design of the modern plumbing system was perfected over 200 years ago? That miracle was the S-bend, invented in 1775 by Alexander Cummings. 105 years later, Thomas Crapper modernized the S-shaped pipe into a U-shaped design that we still use today. It's often called a P-trap. P-traps are that curved section of a drainage pipe. You can see this curve in most drains. The trap holds water, which prevents sewer fumes from backing up into the home. The use of P-traps is an extremely important invention in plumbing, but they weren't universally accepted until much later. In the beginning, there were several other forms of traps designed to do the same thing in theory, just slightly different configurations. Common around the time this house was built was a drum trap. Several of them were removed when we demolished the plumbing system. Here's an example of one that was removed. It's made of lead. The drain pipe from the sink or the shower or wherever is connected down to the lower bottom portion of the drum, which fills up with water, and then the water escapes through this upper one. See how they're offset? That's so water can stay in the bottom when it's not in use and act as that block for that sewer gas from entering and coming back up through the drain pipe into the house. Now, these have a lot of problems. They're prone to clogging, and modern traps aren't. The P-trap, I should back up and say, it's something called self-scouring. The water flows through at such a high velocity, and with the shape of the trap, it actually carries with it anything that falls into the drain. So, it's not kitchen grease. We won't talk about kitchen grease buildup. That's a sore spot with my husband. We won't talk about Thanksgiving turkeys in front of him. But aside from that, anything loose would get swept away from a P-trap. Here you can see it would just fall to the bottom. So it doesn't self-scour. It's going to build up debris and hair and eventually clog and have to be cleaned out. And the problem is that because it can get clogged easy and has to be cleaned out, you need access to it. And a lot of times these are under floors and in places where you just can't get to them. And then there's another problem in that, well, this one is lead. Sometimes there are other materials, but lead is very soft and it gets corroded and this top gets stuck on. And when you try to get it off, instead of the top coming off, the lead just distorts and bends and gets mangled. So a lot of times you'll get a catastrophic failure, to the trap, and it's just not a great design. There are some applications where they're helpful. If you have something, that's at risk of falling down the drain that's important and you don't want it swept away, there's a strategic advantage to having one. In fact, you can still buy them. Here's a modern drain trap that's advertised to be installed on a lavatory and sink in dormitories, motels, beauty salons. It's a safeguard against losing rings and other valuables and jewelry due to accidental dropping in the lavatory drain. And that's advertised that it can be easily cleaned. I would imagine that hotels get quite a few calls from panicked guests who have dropped rings down the sink, or dorms where kids dump who knows what down the drain. That's a very specialized application. You won't find these in residential homes anymore. Other types of traps have been used, but they all had one problem or another. Remember that incredible original trap that was on the sink in the family bathroom? Over time, the P-trap won the design challenge, and it's almost exclusively used today. So, how do traps affect the plumbing layout here in the basement? Every fixture is required to have either an internal or an external trap. An example of an internal trap is in a toilet. That swirly S shape that you see on the side, that's actually the trap, as opposed to a sink that has a trap underneath that you can see when you open the cabinet door, or a shower, which if it's on the first floor is buried underground. Another problem with traps is that water can get sucked out of them under certain conditions, and then that lets that sewer gas come in and creates a stinky mess, because that's what the trap is designed to avoid. In Victorian times, people died from toxic gas, or houses blew up when the combustible sewer gas accumulated and the house ignited itself. Think of the gas lighting in a house. Other traps didn't allow wastewater to flow freely, and that kept pipes from draining. Most of these problems were alleviated when plumbing experts discovered that adding an extra pipe to a drain allows air to flow into the drain system, correcting a lot of the problems with early traps. That theory is called venting theory. It was widely practiced around 1874. Let me show you an example that I bet everyone is familiar with. Who hasn't put their finger over a straw and lifted it out of the glass to see your favorite beverage trapped inside? Your drink is stuck in that straw because no air can enter in from above. You've created a vacuum. All you have to do is remove your finger to allow air to flow through the top of the straw, and presto, the liquid drains out the bottom. That is the sum total of all the science you need to know related to plumbing vents. But theory and practice are two different things. Every plumbing fixture must have a vent, and all those individual vents have to be connected to a bigger vent that then has to exit the house, usually at the highest point of the roof. Because again, you don't want sewer gas venting near a window where it can make its way back inside. Where in the system the air gets in is not quite so easy, and you have to be a genius to read and understand the plumbing code. There are all kinds of distance requirements, pipe diameter, wet and dry vents, special circumstances, and on and on. These are tricky things that can cause trouble and make you fail the plumbing inspection. In this house, because we were working under the constraint of the house's existing layout, venting was the trickiest problem that had to be solved, and actually took quite a bit of time and consultation with the inspector. When we get to the point of putting those vents in and getting them up to the roof, I'll show you some of the issues. With all the venting issues resolved, though, it was time to get to work. Some trench work had already been done, but there was a lot more to do. Part of the plumbing code has different requirements for laying drains in undisturbed soil versus disturbed soil. If we dig down too far and have to fill back in, that's considered disturbed soil. So there's actually an art to that final digging, and David, the plumber, wanted to do that himself. The code may seem like a big pain in the you-know-what, but everything in there is to make sure your waste system works, and you want it to work. Let's use the digging as an example. If I lay a pipe in a trench that I dug too deep and filled back in some, Over time, that loose dirt will settle and compact. That may pull the pipe down, creating something called bottoming out. It's basically a dip in the pipe that can hold water and waste solids, and your system can clog and stop draining properly. I have this happen all the time on our rental property, where just over time, pipes in the soil settle. And imagine it in your house where you've got a concrete slab over it. How are you going to fix that? It's not cheap or easy to fix. So as I always say, the inspector is my friend. The inspector protects me from future problems and keeps me safe. Getting the pipe laid inside the house, connecting the pipe to the outside was a big problem also. Once the pipe was laid in the house, getting it connected to the outside was another big problem. Remember that whole fiasco trying to get a structural engineer to give me a certification so we could drill a hole through the foundation wall to get from inside the house to the outside? Well, the requirement came back that we had to bore with a boring tool, that we couldn't use a jackhammer and knock a hole in it. And boring is not that easy of a thing to do. And this is where I actually recovered a little bit of my video in the basement and can show you what went on there. I was messing with the window, guys, and missed the plumbing delivery. But it's here. It's over $1,000 worth of pipe. Oh, and I've got that two-way clean out upstairs.
Okay.
I need to bring down to you.
Oh, one more box over. Something's missing.
Just checking to make sure everything's here. And the window guys are loading up.
Okay, everything's.
David's about to start drilling the wall from the inside. They've dug out the pipe and put a reducer down to 4 inches, which will then have a double clean out and go into the house through a 4-inch bore. White line where you have to bore
Yeah, we have to go down a little deeper.
to get the boring machine in there.
So basically, it's another at least 6 inches of break underneath out here. That's it. All the way to that.
So it's into the footing.
So that's a complicated piece, but
The other option is I can 45 up off of that transition from the 6 to the 4. I could come off, put the two-way clean out, 45 up, and then 45 back, and come in higher.
As long as you have the slope to get to that far.
That's the thing. I don't.
Because you're going to lose 2.5 inches
So as long as
or
we don't
more.
come higher than this trench here,
it shouldn't affect what we just did.
right?
I just put the laser in right.
So if it's true on the inside, it's going to be true on the outside. I mean that.
That flange comes up.
Yeah, that's the top. That white line is the top of the pipe outside.
Top of the pipe.
So we need to go 8 inches. We need to go 6 inches down from that line.
Is there also step out on the outside as well? Like this?
Is that?
Is the foundation
Oh, I'm sure
step
there
out?
is, but we're just not that deep out there. We didn't need to. What's the worst that it could happen?
What's the worst thing that can happen? I don't. At the building.
Exactly right here, so the window will fall over me.
That window's not going anywhere.
All right.
I'm just looking at these reinforced beams here. I think that's where I'm going to stand.
Yeah, trust me, this house isn't going anywhere.
All right, let's thread that bad boy onto the
We've
machine.
been through earthquakes in Mexico.
That looks like a t-shirt shooter.
Yeah, stand back over there and I'll shoot you one. Well, either that or I try to drill it as tight as possible and push it through.
Oh no, I will fill it with something. Well, I'm sure there's something. There's pond foam.
Adapter.
There's an adapter. This has a...
So this will take water, but I think this is going to be, the brick is going to be soft enough I won't need it.
The brick's not hard, I can tell you that.
Yeah. All right, you're live.
Joe, who you love?
Grab him with your safety glasses.
He's here.
You need safety glasses.
Here. Oh. Here's mine.
Good one.
David first started boring without the hose attachment. After just a minute or two, it was obvious that things weren't going well. He stopped and we regrouped. The water hose was brought in and attached to the boring machine. The water acts to cool the bit, and it's also a lubricant. I know this thing doesn't look like much, but it exerts an extreme amount of torque. Torque is a measure of force that can cause an object to rotate about an axis, just as force is what causes an object to accelerate in a linear motion. That just means there's a lot of force rotating that cutting edge, and if you don't have a good grip, the bit will seize up in the brick, and the part you're trying to hold on to will wrench itself out of your hands. I've had this happen just with my regular drill, and it can be quite painful when you're hanging onto that drill bit tight and then suddenly the bit seizes and your wrist gets jerked all of a sudden. I thought it was very clever that they used a long piece of PVC pipe to put on the handle that you normally hold on to. This is application of another physics concept, the lever. A long lever means that less force is needed to keep the motor end of the bore stable. David was still working pretty hard, but it was really helpful and sped things up quite a bit. It was still a slow process because after drilling for just a minute, the hollow portion of the bit is deeply embedded in the brick, and that's what causes it to seize up. To counteract that, David would have to stop every minute or two, knock the brick free, and then shake it out of the boring bit, and then repeat the whole process. You can see him shaking out those cylinders of brick. David sat in that hole and bored for about 4 hours.
Is Joe able to bust it through from, you know what, there's a crowbar over there. Let me put them in the holes and see if I can pop them.
Can you bring the sledgehammer in from this side and just tap it?
Yeah.
The diameter of the bore is actually relatively small, and we needed a 4-inch minimum sized hole to get the plumbing through. So instead of just boring one big hole, David had to bore a series of smaller holes around the circumference of the opening that we needed. That's one of the reasons it took so long. Once he'd gone around the outside, he could break out that middle part that was left. It was just hanging on because the length of the boring bit just barely reached the outside of the wall. Then it was time to head outside and put on the two-way clean out and run the pipe through the wall.
Okay, the reducer should already be primered. Yeah. Okay. Make sure you get it straight up and down. Let's get a scrap piece of 4-inch to put in there. Hold on, hang on. Hang on. Let me get to that other 4-inch piece. I want to make sure that thing's coming out of the ground.
have no idea how they were able to work in that cramped space. This was a big guy in a deep, small hole, and he had to bend down and work at the very bottom of it. I tried to get in that hole once to rescue a frog, and there was no way. It was actually very impressive to watch.
Thanks for telling me that. Just making sure.
Must be related to my husband.
Well, it's a drain, so.
I know, he's always
Part where the water's flow.
He's always telling me stuff. I'm like, yeah, I know. I taught you how to do it. But thank you. All the cooks are in the kitchen.
All right, you almost ready?
What?
You ready? Not quite? Okay, I'm just putting the glue on right now.
I know most of you won't be too excited to watch plumbing, but I was positively giddy at this point. Getting the sewer line installed and seeing it being connected through this wall was 19 months in the making.
Thank you.
You want to glue the other side?
Okay. Oh, did you put
You didn't glue on the inside?
Inside? I did.
Oh, we did. Oh, I didn't see that.
Yep, a little more. You need to put the sleeve in a little further up. All right, I think that's all the way. What? I think that's all the way in.
Okay, we are back at it this morning on the plumbing. It should go much faster. All of the venting issues have been resolved. David, the plumber, called the inspector yesterday and talked to him about a way to vent the toilet. And the inspector has agreed. It's really important because, you know, Victorian bathrooms used to blow up all the time because they didn't understand methane gas and all the issues with plumbing. The code is there for safety and to make sure things like that don't happen today. So we want to make sure everything is going to pass the inspection before we get it all glued up. So better to talk to the inspector ahead of time and just confirm what we're doing, because we are doing something a little bit different than you'd normally see, but still meets code. It's a thing of beauty.
That stands for finished
I was
floor.
looking at the wall.
That stands for finished floor. So
So what? So you're putting just roofing mastic?
yeah, so it creates like an expansion around the pipe. That way the concrete doesn't get right up against the
So
pipe.
if they come in and lay the floor and it ends up slightly different, we just need to make sure that the full penetration has that on there.
Yeah, but I mean, I think we're pretty close.
Okay. You never know. I'll
Yeah.
change our mind around here.
So do you want me to go to the red line at the top or just go a brush stroke
Well,
higher?
so if you look over there at that height, you can kind of guess where you need to be. Yeah, you can.
So it was a long day yesterday. These guys were here from 7:30 in the morning until about 8:40 last night. There was some problem holding pressure, and it turned out the test caps were allowing leakage, so they went at 6 this morning and got these other kind of caps to put on. It's now about 8 o'clock and they've been holding pressure for an hour, so finishing up a few little things and they'll call for an inspection. But it's looking pretty good. So at the end of the day, yay! We have a permit, we are cleared. There's a ton of work still to do in the basement. The rest of the floor has to come out. We have to bring in new sand, get everything level, pour a slab, and start building partition walls so we can run electrical and the water lines and the drain lines up the wall. There will be a flurry of activity down there over the next 6 to 8 months. So someday we'll get out of the basement. not anytime soon, but at least everything's going in the right direction. We're not going to be tearing things up. We will be building back. So I'm super excited. So be sure and subscribe and turn on your notifications because there is a ton of work left to do in this house. We are just getting started. And this is a big, big step. Thanks for watching. We'll see you next time at the League-Kempner House here in Galveston, Texas.